this video, we'll talk about the new REST APIs in Alfresco 1 5.2. REST APIs has been growing rapidly over the last 10 years and has really become the foundation of a platform. REST APIs are essential when developing a custom application from the ground up. They are the main entry point for developers, especially in a modern cloud world where a lot of the services only provide a simple web interface and a good REST API. Today, a product, service, platform, or infrastructure are expected to have a good set of REST APIs. Amazon and Google are great examples as they provide a simple and fluent REST API to interact with their services. In the past, REST APIs were often a byproduct of development and integration efforts. Often an internal or private API was made public without putting too much thinking or effort into it, and as a result, the APIs would vary in quality and documentation wasn't always great. Today, we see more and more companies treating their REST APIs as a product and as a first-class citizen spending a lot of resources on promoting and marketing their APIs. Alfresco has always had a REST API along with CMS and the ability to create custom APIs via web scripts. However, seeing the growth of REST APIs over the recent years, we have decided to create a new set of REST APIs to empower our developer ecosystem. Developing a good, fluent, and consistent REST API is not an easy thing to do. Some of the key elements we wanted to address was consistency, stability, backwards compatibility, which can be achieved through versioning, and documentation. Treating our REST APIs as a contract has forced us to think differently about designing and implementing them. We use OpenAPI specification to design and describe our APIs, followed by intense peer review to make sure they are robust and consistent. The REST APIs are now versioned to ensure backwards compatibility. The version represents the requests and responses, not the features. We will additively change the APIs, but in a backwards compatible way, for example adding new endpoints or additional parameters to existing endpoints. Another advantage of using OpenAPI specification is that we can generate documentation using a tool called Swagger UI. The end result is an interactive reference guide to the APIs where you can explore and test all the endpoints directly in the browser. Consistency is really key when designing a new REST API. You must have the correct usage of HTTP verbs, and you must have a clean and consistent URL structure. The OpenAPI specification enables us to reuse different representations across the different endpoints. This means that the representation of a node will be the same whether you're requesting a collection or a single node, or whether it's coming from the Nodes API or a Shared Links API. A node is a node, and you can expect the same consistent results across all the endpoints. Extensive peer reviews help us ensure consistency, and this is not just from a developer to developer, but the architects are also involved in the process. Correct usage of HTTP return codes is also important. The API should never return an error 500 internal server error. It should give you back the proper HTTP status code with a corresponding error message to indicate what went wrong. Let's have a look at the URL structure in the new APIs. The first part is the tenant ID. If you're in a multi-tenant environment or in the cloud, you'll have a unique ID you need to put in here. If you're on-prem and you only have one tenant, it will be -default-. Then we have the scope. Most of our APIs will be public, but we do have a few ones that are private or internal. We try to make both the private and internal APIs as good and consistent, but they are subject to change, and you should only be using the APIs that are in the public scope. The next part is the API name. This identifies which subsystem of the repository you're working with. Most of our core APIs are in /Alfresco, but other examples would be /authentication, /search, or workflow, or discovery. Then we have the version number. Currently we are on version 1. The last parts are the resources you are requesting. We have split this into an entity, an ID, and a relationship. In this example, we're requesting the children of a given node. Here we see some examples of the different URLs of the APIs. In the first one, we're requesting the root node, which is an alias that ties in with company home, so we'll get one node back, which will be company home. The second one, we get the authentication tickets for me, which is again an alias for the current logged in user. The next one, we're getting a list of processes, then get a list of sites, list of people, and the currently logged in user. Here you see some of the entities that we include in the APIs in 5.2. Nodes, renditions, sites, people, groups, tag, workflow, network. On the right hand side you can see an example of what an entity looked like. Writing documentation for REST APIs can be a challenge. Luckily, the OpenAPI initiative has a lot of tooling. One of them is called Swagger UI, which allows us to generate interactive documentation based on the API specification. We've customized the Swagger UI and packaged it up as a raw file, and we call that the Alfresco REST API Explorer. This is a complete reference guide for all our REST API endpoints, where you can see interactively the responses, the requests, the parameters, the response codes, the headers and everything. And it even has a try it out live button, so you can fill out the form for all the parameters, click try it out, and you'll see the response directly in the browser. Here we see the REST API Explorer. In the top right hand corner, you can see a drop down where you can select the API you want to work with. By default, the core API is selected, but you can also choose search, authentication, discovery, and workflow. Next to the drop down, you can enter the username and password credentials you want to use for the try it out feature. 5.2 brings a lot of new endpoints, nodes, queries, rendition, shared links, trash can, just to name a few. For this demo, we'll have a look at the nodes API. This API contains common features like create, update, delete, but also copy, move, lock, unlock, and associations. Let's have a look at the endpoint to get a node. In the first section, we see the schema, the full response you can get from this API. In the next section, you can see all the parameters the endpoint take, like node ID, include, and fields. At the bottom, you'll see the try it out button. Since the page is interactive, let's try and get the company home folder. We have aliases in place for common folders like user home, company home, and shared links, so in the node ID we can simply enter -root- and hit the try it out button. The first thing we see is a curl command, which is handy if you want to run this call in the command line. Next you'll see the full request URL followed by the response body. Here we can see the nodes entity. By default it will contain a base set of information like name, ID, creation date, and aspects. The response can be customized via the include and fields parameters. Include allows you to add extra information about the node like path, log information, and allowable operations. The fields parameter does the opposite. Here you can specify the exact information you want to minimize the response. Include and fields are two common parameters you'll see across any API that returns a node like listing children or search. Let's try and make this endpoint only return the ID and the node name. We do this simply by entering ID, names in the fields parameter and click the button. Notice the response is much smaller and contains exactly the information we requested. Now let's try and list the children of company home. We do this by using the /children relationship on the node ID. The list children endpoint is a good example of getting a collection of entities. Pagination and sorting are all implemented in the exact same way across all the APIs, whether you're getting a list of nodes, sites, people, or search results. Most listing APIs support a where clause that enables you to filter the results list. For the Nodes API, you can choose to limit the results to only include files or folders, or you can filter by a certain type or association. Again, you see the include and fields parameters like we saw in the nodes. Let's try and grab the subfolders of company home and only display the ID and the name. We do this by entering ID and name in the fields section and set the -root- as the node ID, then we click the button again. Notice the list entry in the response. This contains all the pagination information like total items, max items, and skip count. We've designed this with a client application in mind, ensuring this information is always available and makes it easy to construct pagination features in the UI. The entities is a collection of nodes. Here you can see all the subfolders only displaying the ID and the name exactly like we requested. We realize this is only a quick and short view of the new REST APIs. We encourage you to go and look at the REST API Explorer to learn all the details on how to work with the new APIs in Alfresco 1 5.2.